Good morning, my algebros. Now we are looking at 3-3, writing functions, part 2. Yes, part 2, because part 1 we did with crossing the river. Today we're looking at independent and dependent variables and evaluating functions. First of all, let's take a look at identifying what would be an independent versus a dependent variable. Let's look at some scenarios. In the winter, more electricity is used when the temperature goes down, and less is used when the temperature rises. So what is being affected here? The electricity is being affected by the temperature, right? So we know the amount of electricity depends on the temperature. And so the amount of electricity is the dependent variable, which would be the y, by the way. Yep, this means that this is the y. And the independent would be the temperature, which is also known as the x. Number 2, the cost of shipping a package is based on its weight. And we have talked about this so many times, and we will talk about this, but cost is always the y, and it's always dependent on the x. So we know the cost is going to be dependent on the weight of the package. The dependent variable, or y, is the cost, and the x, or independent variable, is the weight. Let's write a function. A lawyer's fee is $200 per hour for her services. So the fee of the lawyer depends on how many hours she works. So the fee is dependent, or the money is always the y, as we've said before, and it's dependent on how many hours. So we're going to let h represent the number of hours the lawyer works. So we would write the function for the fee of f of h, or the function of the hours, which we also know is the y, the combination. How many hours, how much is it going to cost, is going to be $200 an hour, right? So that's how much the fee is going to be. The administration fee of a local carnival is $8, and the ride costs $1.50. So now we have what we know as we will be learning as a y-intercept, or an initial fee. And that $8 is the initial fee plus $1.50 per ride. So we know the cost, or the y values, will be dependent on how many rides we take, right? So we let r represent the number of rides that are going to be ridden, and the function of the total cost will be f of r equals $1.50 per ride plus the initial fee of $8. Now let's evaluate some functions. If we're given the input, or we're given the function, what would be the output? So if we have f of x equals 5x minus 3, what is the y value going to be when x is 3 and when x is 4 and x is negative 3? Well, I plug it in. If f of x when x is 4, what will our y value be? It'll be 17. Right? Or we also know it as y equals 17. To write this as a coordinate on a graph, I would say x is 4. When x is 4, y is 17. So we're going to plot that like we did on crossing the river. Let's look at the next one, negative 3. When f of x equals 5x minus 3, and when x is negative 3, well, y is going to be negative 18, right? We know y is going to be negative 18, so our point that we would have is negative 3, negative 18 if we were going to graph this. Let's find g of x. Whoa. What's the deal with the g? Well, on a graph, we might have more than one function that has been displayed. So we need to understand that we can have a function be labeled with a different letter. So f of x, the function of x, this is g of x, but we know it's a function. The line would be called g instead of f. So in here, the f of x is x squared plus 2x when x is negative 4 and x is 3. So if the x value is negative 4, well, negative 4 squared is going to be 16, negative times negative. And then negative 4 times 2 is negative 8, giving us y is 8. Or when x is negative 4, y will be 8. If g of 3, or when x is 3 squared plus 2 times 3, that is going to be 9 plus 6, giving us 15, right? Or we could say that when x is 3, y will be 15, and that will be the point on the plane. Or if I were to go ahead and use the table, that's another way of seeing it. I'm sorry about the extra writing on there. It happens. So we could do negative 4 and 8 and 3 and 15. You try. You can go ahead and pause the video after the problem is written down and solve it. And then check your answers when you're ready. So the answer here, when x is 1, y is also 1. And when x is negative 3, y is negative 7. You want to see why? Well, check it out. If f of 1, or when x is 1, y is also going to be 1. When x is negative 3, well, y is going to have to be negative 7. The homework for this part of our work today is 3-3 in your textbook. We're doing 13 through 35. Now stay tuned, because we have a second part of our lesson today, because it's a block day, and why not?